Hi everyone, welcome to Drawing Hubs. So this is Computer Graphics Part 2 of Module 1. So the previous video we have completed the basics of computer graphics and its application. Now we have video display devices, refresh ray cathode ray tubes, random scan displays and systems, raster scan displays and systems. Moving on. Now the overview of graphic system. Due to the widespread recognition of the power and utility of computer graphics in virtually all fields, a broad range of graphics hardware and software system is now available. The video display devices, typically the primary output device, okay, make sure you note this. The primary output device in the graphics system is a video monitor. Okay. The operation of most video monitors is based on the standard cathode ray tube CRT design, but several other technologies exist and solid state monitors may eventually predominate. This much you have to write as the introduction of video display devices. Now moving on, we have to the subheading refresh cathode ray tube. We have a figure of the refresh cathode ray tube. This is the magnetic deflection CRT, basic design for the magnetic deflection. Now this figure illustrates the basic operation of a cathode ray tube. Now what happens over here is, if you have noticed, we are having connector pins over here. These are the connector pins. We have the connector pins, which is attached to a base. The connector pins is attached to a base. Then here we have the electron gun. The picture might not be clear. Here we have the electron gun. And then through the electron gun passes the electron beam. And here we have the focusing system. Then this bulge over here is the magnetic deflection coil. Then we have phosphor coated screen. This is the basic design of a magnetic deflection CRT. We have the connector pins, a base. The base electron gun is connected to the base. Then we have the focusing system, and electron gun releases electron beam. We have the magnetic deflection coil and the phosphor coated screen. Now the figure illustrates the basic operation of a cathode ray tube. A beam of electrons, cathode rays, emitted by an electron gun passes through focusing and deflection system. See, it passes through the focusing. This much is the focusing system and this much is the deflection system. So, a beam of electrons emitted by an electron gun passes through the focusing and deflection system that direct the beam. Towards specified positions of the phosphor coated screen. So the focusing system and the magnetic deflection system is the one which determines where the electron beam should reach on the phosphor coated screen. The phosphor then emits a small spot of light at each position conducted by the electron beam. So wherever there is a contact of the electron beam, the phosphor will emit a small spot of light. Okay. Because the light emitted by the phosphor fades very rapidly, some method is needed for maintaining the screen picture. So this does not last for long, it will fade very rapidly. And for that, to keep the phosphor glowing, we have to redraw the picture repeatedly by quickly directing the electron beam back over the same point. So it will be redirected. To redraw the picture repeatedly, we have to direct the electron beam back over the same point. Now, this type of display is what we call as a refresh CRT. This is what we call as a refresh cathode ray tube. The primary components of an electron gun, then we go deep into electron gun. So this is about the refresh cathode ray tube. So 3 marks and all, if it is asking, we can write the refresh cathode ray tube. We'll draw the picture and along with that, we'll write what all is needed. Then coming to the electron gun in a CRT. This is the diagram for electron gun. So electron gun, we are having an heating filament over here. See the heating filament, which is surrounded by the cathode, and that is surrounded by the control grid. This is the control grid. This is the heating filament. This is the cathode. We have the control grid, and then we have the focusing anode. This is the focusing anode, and then we have the accelerating anode. And through it you can see a small space through which the electron beam passes. Electron beam passes through this. Okay, this is the figure of an electron gun with an accelerating anode. Now, the primary components of an electron gun in a CRT are the heated metal cathode and the control grid. We are having the heated metal, having the heating filament, the cathode and the control grid. So, this much is the primary components of an electron gun. Okay. Now, heat is supplied to the cathode by directing a current through a coil of wire called the filament. Now, we have to apply heat to the cathode. So, how is heat applied to the cathode? From the heating filament, it is a coil. Now, current is applied to this coil, making the cathode heated. Inside the cylindrical cathode structure. So, inside the cylindrical cathode structure is where heating filament is present. Now, this causes the electron to be boiled off the hot cathode surface. Now, the electrons in the cathode surface will be boiled off. Okay. The hot cathode surface. In the vacuum inside the CRT envelope, the free negatively charged electrons are then accelerated towards the phosphor coating by a high positive voltage. So now it is vacuum over here. Okay. Inside this tube, it is vacuum. In the vacuum inside the CRT envelope, the free negatively charged electrons are then accelerated towards the phosphor coating by high positive voltage. Now here, since it is heated and it is vacuum, this tube is vacuum. Now the electrons will accelerate towards the phosphor coated screen. Now it will approach the screen or the phosphor coating with a high positive voltage. The accelerating voltage can be generated with a positively charged metal coating in the inside of the CRT envelope near the phosphor screen, or an accelerating anode can be used. So we can determine the voltage using the accelerating anode. Sometimes the electron gun is built to contain the accelerating anode and focusing system within the same unit. So this accelerating anode and focusing unit, in some cases, both these systems will be in the same unit. That is also possible. Okay, these both come under the same unit. Now, intensity of the electron beam is controlled by setting voltage level. Now, we are having this control grid. Okay, the control grid, why is it used? You can see over here the control grid over this part. Now, this is used to control voltage levels. Intensity of electron beam is controlled by setting voltage levels on the control grid. Now, this control grid is a metal cylinder. The control grid is a metal cylinder. Okay. It is a metal cylinder that fits over the cathode. So look, it fits over the cathode. It's above the cathode. Okay. A high negative voltage applied to the control grid will shut off the beam by repelling electrons and stopping them from passing through the small. Now, if a negative voltage is there, the number of electrons passing through this hole will be reduced. But if it is a high negative voltage, then the electrons will stop passing through this hole. Okay. By repelling electrons and stopping them from passing through the small hole and the end of the control grid structure. Now, smaller negative voltage on the control grid simply decreases the number of electrons passing through. Since the amount of light emitted by the phosphor coating depends on the number of electrons striking the screen, we control the brightness of a display by varying the voltage on a control grid. Okay. Now, why this control grid is used? Because the intensity of the light is determined with the help of the voltage of the electrons. So, that we can control using the control grid. We can control the intensity of the control grid of the electrons using the control grid. That is why we are using control grid. Now, the focusing system in a CRT is needed to force the electron beam to converge into a small spot as it strikes the phosphor. Then we have the focusing system. Now, where is this focusing system? The focusing anode over here. So, this focusing system in a CRT is needed to force the electron beam to converge. We have to converge the electron beams, we have to converge it into one spot. Otherwise, the electrons will be repelled each other and they will spread throughout. So, to avoid that situation, we want to converge it. And for that thing, we are using focusing system. The focusing system in CRT is needed to force the electron beams to converge into a small spot as it strikes the phosphor. Otherwise, the electrons would repel each other and the beam would spread out as it approaches the screen. Focusing is accomplished with, now focusing, we do it either using magnetic field. So here, in this case, it is magnetic deflection. We also have electric deflection systems. So, electric deflection systems are also possible. Now, the focusing system in a CRT is needed to force the electron beam to converge into a small spot as it strikes the phosphor. Otherwise, the electrons would repel each other and the beam would spread out as it approaches the screen. Focusing is accomplished with either electric or magnetic field. Electrostatic focusing is commonly used. Now, this electrostatic focusing, it is commonly used in television and computer graphic monitors. With electrostatic focusing, the electron beam passes through a positively charged metal cylinder that forms an electrostatic lens. Now that we have over here. There is electrostatic deflection of the electron beam. Again, it is similar to that of magnetic deflection, but the deflection systems are varying. That is, over here we have the base, we have the connector pins connected to the base, we have the electron gun, and we have the focusing system. Then we have the electron beam passing through it, and we have the phosphor coated screen. So this much things are same. But when it comes to the deflection system, you can see that the bulge over here for deflection system, that is not there in this case. Instead, we have horizontal deflection plate and vertical deflection plate. Horizontal deflection plate and vertical deflection plates are found. This is how this is horizontal deflection plate and this is vertical deflection plate. Okay. Now, additional focusing hardware is used in high precision systems. So this is more detailed about the hardware and focusing systems. As with focusing, deflection of the electron can be controlled either with electric or magnetic field. Now, it is usually cathode ray tubes are now commonly constructed with magnetic deflection coils mounted on the outside of the CRT envelope. So, in this case, we use two pairs of coils with the coils in each pair mounted on opposite side. This is the structure of how it is formed. Okay. Now, we'll go through the details of it. Okay. This is the refresh cathode ray tube. The primary output device in a graphical system is the video monitor. It is a specialized vacuum tube. As I told you, the envelope is vacuum. A specialized vacuum tube in which images are produced when an electron beam strikes a phosphorescent surface. We have connector pins, base, electron. This image is much more clearer than the one in the text. We have the focusing system, and this is the magnetic deflection coil. This one is a magnetic deflection coil. Okay, and you have phosphor coated screen and electron beam. Then we have refresh ray cathode ray again. This one is the electrostatic deflection one. Here we have the horizontal deflection plate and the vertical deflection plate. The rest everything is same. Now, a beam of electrons emitted by an electron gun passes through the focusing and deflection system that direct the beam towards specified positions on the phosphor coated screen. The phosphor then emits a small spot of light at each position contacted by the electron beam. Because the light emitted by the phosphor fades very rapidly, some method is needed for maintaining the screen picture. One way to keep the phosphor glowing is to redraw the picture repeatedly by quickly directing the electron beam back over the same point. This type of display is called a refresh cathode ray tube. And this is the operation of an electron gun with an accelerating anode. We have the heating element, the cathode, the control grid, the focusing anode, the accelerating anode, and the electron beam path. Now, the primary components of an electron gun in a CRT are the heated metal cathode and the control grid. Heat is supplied to the cathode by directing a current through a coil of wire called the filament. This causes electrons to be boiled off the hot cathode surface. Intensity of the electron beam is controlled by setting voltage levels on the control grid. The amount of light emitted by the phosphor coating depends on the number of electrons striking the screen. Then refresh cathode ray tubes. The intensity of electron beam is controlled by setting voltage levels on the control grid, which is a metal cylinder that fits over the cathode. A smaller negative voltage on the control grid simply decreases the number of electrons passing through the small hole at the end of the control grid structure. A high negative voltage applied will stop electrons from passing through it. The focusing system forces the electron beam to converge into a small spot as it strikes the phosphor. Otherwise, the electrons would repel each other and the beam would spread out as it approaches the screen. Focusing is accomplished with the help of either electric or magnetic field. Now, deflection of the electron beam can be controlled either with electric or magnetic field. Horizontal deflection is accomplished with one pair of coil and vertical deflection by the other pair. When electrostatic deflection is used, two pairs of parallel plates are mounted inside the CRT envelope. So, one is horizontally and other one is vertically. So, horizontal plate is to control the vertical deflection. We are using the horizontal plate. We are having two horizontal plates, that is to control the vertical deflection, and we are having vertical plates to control the horizontal deflection. Free negatively charged electrons are accelerated towards the phosphor coating by a high positive voltage. The accelerating voltage can be generated with an accelerating anode or with a positively charged metal coating inside the CRT envelope near the phosphor screen. When the electrons in the beam collide with the phosphor coating, they are stopped and their kinetic energy is absorbed by the phosphor. A part of the beam energy is converted by friction into heat energy, and the remainder causes the electron in the phosphor atoms to move up to the higher quantum energy levels. After a short time, the excited phosphor electrons begin dropping back to the stable ground state, giving up their extra energy, a small quantum of light energy. Now here, video display devices. The primary output device in a graphic system is a video monitor. The operation of most video monitors is based on the standard CRT, cathode ray tube. But several other technologies exist and solid state monitors may eventually predominate. Now, display devices, we have CRT, raster scan display, random scan display, color CRT, direct to storage, and so many examples are there. Now, coming to cathode tube, the figure over here is not here, but now working. A beam of electrons emitted by an electron gun passes through the focusing and deflection system that directs the beam to a specified position on the phosphor coated screen. The phosphor then emits a small spot of light at each position conducted by the electron beam. Because the light emitted by the phosphor fades very rapidly, some method is needed for maintaining the screen picture. One way to keep the phosphor glowing is to redraw the picture repeatedly by quickly directing the beam back over the same point, and this type of display is what we call the refresh cathode ray tube. Now the components of cathode ray tube are electron gun. The electron gun is made up of several elements, mainly a heating filament and a cathode. The electron gun is the source of electrons focused on a narrow beam facing the cathode ray tube. Focusing and accelerating anode. These anodes are used to produce a narrow and sharply focused beam of electrons. Otherwise, the electrons will repel each other and they will spread out. Vertical and horizontal deflection plates. These plates are used to guide the path of the electron beam. The plates produce an electromagnetic field that bends the electron beam through the area it travels. Phosphor coated screen. It is used to produce bright spots when the high velocity electron beam hits it. The intensity distribution of an illuminated phosphor spot on a CRT screen. That is a graph of it. The figure shows the intensity distribution of spot on the screen. The intensity is greatest at the center of the spot and decreases with the Gaussian distribution out to the edges. See, in the edges it is low and in the center it is more. The maximum number, distribution out to the edges of the spot. Next, the definitions about the CRTs we'll discuss in the next video. So then, bye bye.